Welcome to The Explainer. Have you ever wondered what is actually going on inside the mind of an AI like ChatGPT? Well, today we're going to follow your question on its wild journey from your screen, through the machine, and all the way back again.
From our end, it seems pretty simple, right? You just type something into a chat box, you hit enter, and bam! A few seconds later, this perfectly coherent, sometimes shockingly detailed answer pops up. It feels like magic.
So what really happens in that split second? Let's actually trace that journey. We're going to follow your prompt from your keyboard deep into the complex digital brain of the machine and see how it comes back to your screen as a complete thought.
Okay, first things first, we've got to meet the star of our show, the large language model, or what you'll hear people call an LLM. This is the engine that drives everything.
Now, at its absolute core, an LLM isn't a thinking machine the way we are. It is an incredibly powerful prediction engine. You have to remember its entire existence is basically dedicated to one single job, guessing what word should come next.
So here's the crucial part. When it sees this phrase, its massive neural network just analyzes the pattern and calculates that the most statistically probable next word is gold. It's not understanding Shakespeare, it's mastering the pattern. And it just does this over and over, one word at a time, to build out entire sentences and paragraphs. But, to predict the next word, the AI has to really understand the words you've already given it. And this isn't some simple dictionary lookup, it's actually a super sophisticated two-step process that turns our human language into something a machine can finally understand. You can think of it like a language assembly line. First up is tokenization, which breaks your sentence into meaningful little chunks called tokens. Then comes vectorization. This is where each of those tokens gets its own set of coordinates, placing it on this giant, multidimensional map of meaning. On this map, words like happy and joyful are super close neighbors, while opposites like hot and cold are, on totally different sides of the globe. This map is how the AI gets the relationship between words. Okay, so here is where it gets really interesting. How does the AI handle the absolute trickiest part of human language? Words that mean completely different things depending on how you use them. In a sentence like this, that vector for Apple needs to be sitting in the neighborhood with other companies, right? Like Google and Microsoft. We are clearly talking about a corporation. But then you get a sentence like this. The AI needs to understand that the exact same word, apple, is now a fruit, and it should be placed next to banana and orange on its map. The spelling is identical, but the meaning is worlds apart. So how does it solve this puzzle? Well, the answer lies in this pretty revolutionary concept that came out in 2017, and it fundamentally changed the entire game for artificial intelligence. It's called the attention mechanism, and honestly, it works a lot like we do. The AI looks at the surrounding words for clues. It pays attention to the word revenue and knows to shift the meaning of apple towards company. It sees tasty and immediately shifts it towards fruit. This is what lets the model grasp true contextual meaning. And this right here is the genius behind what's called the transformer architecture. By stacking multiple layers of this attention mechanism, the AI builds understanding piece by piece. So the first layer might just figure out that apple is a fruit, but as that information passes up through deeper and deeper layers, the model can start to grasp much more complex ideas, things like sarcasm, subtext, and implication. So we know the AI can understand our prompt, but where did it get all this knowledge in the first place? How did it get so smart about language and learn all these rules and relationships? Well, the huge breakthrough was a shift away from what was called supervised learning. That's where humans had to slowly and very expensively label mountains of data. The new method is self-supervised learning. Here, the model basically gives itself quizzes. It just grabs a sentence from the internet, hides a word, and then tries to predict what that hidden word is. By doing this billions and billions of times, it learns the patterns, the grammar, and the whole structure of human language on a massive scale, literally using the entire web as its textbook. Okay, so the AI has taught itself the rules of a language. But how do we take all that raw knowledge and turn it into a helpful, specialized assistant? Well, that is the final piece of this puzzle. This is a process called fine-tuning. You take that big, general base model, and you give it a very specific job. You can think of it like training a new employee. You reward the good answers, you correct the unhelpful ones, and over time, you gradually shape its behavior and turn it into an expert for that specific task. But there's a big catch. A model's core training is basically frozen in time. It doesn't know what happened in the news yesterday, and it definitely doesn't know about your company's internal documents. To solve this,
we need one last, very clever trick. This is done with a technique called Retrieval Augmented Generation, or RAG for short. It's kind of like giving the AI an open book test. Before it answers your question, the system first goes and retrieves the most relevant, up-to-date documents, say today's news or a specific company policy. It then augments your original prompt with all this new information, giving the AI the fresh context it needs to generate a perfect, relevant answer. So there you have it. From a simple string of text that gets broken into tokens, converted to vectors, understood through layers of attention, and finally augmented with real-time data, that is the incredible journey of your prompt. It's a system built entirely on mathematics and probability, which of course leaves us with the ultimate question to ponder. Is it just an extremely sophisticated prediction machine, or is this the beginning of something more?